You know, it's funny. As soon as we start Unit 11, guess what? We're on the last section already. Welcome back, my friends. We are talking today a little bit more about radicals and square roots. Today we're going to do some simple arithmetic, some adding, subtracting, multiplying, and dividing, things that have or contain a radical. So again, you're going to have to know some things from Section 1 about simplifying a radical, but all in all, we're going to look at a little bit more in how to simplify things that contain a radical. Alright, so the first thing we're going to talk about is adding and subtracting things that have a radical. So, for example, number 1 in our first one, we have 3 times radical 7 plus 2 radical 7. So let's say I get this expression again. I want to simplify it as much as I can. But what we're doing here is we're adding 2 things with radicals, so how the heck do I do this? Okay, so when you add and subtract radicals, you are going to look for what we call, very similar to something we've seen before, we are going to look for what are called like radicals. Very similar to when we looked at things like 2x and x, things that were called like terms. So instead of like terms, we're going to be looking for like radicals. Okay? So imagine if we look at example 1, we have 3 radical 7 plus 2 radical 7. Imagine this were 3x plus 2x. How the heck would we simplify that? Well, all we would do is we'd take the coefficients, the numbers in front, and we'd add those together, and that would give me 5x. So the same thing is going to be true here. When I simplify things with radicals, all I'm going to do is I'm going to add the numbers on the outside. 3 plus 2 are 5, and I'm going to keep the radical as if it were a variable, radical 7. Okay, so this is going to simplify down to 5 radical 7. So notice that it simplifies down just like it would be combining like terms. Now, why are we able to do this? That's the key thing here. The reason why we're able to do this is that both of these radicals contain the same number on the inside. They're like radicals. They both are radical 7. Okay? So another way to view this is something we talked about in Unit 10, which is factoring. If both of these contain radical 7, I can factor radical 7 out on the outside, and I'm simply left with 3 plus 2 that's left behind. So I can take that radical 7 out. Okay? So in example 2, what happens if I don't have like radicals? Does that mean I can't simplify these? Okay, well, this is where we have to think back to Section 1. This first example is easy to do because I have like radicals. So if I don't have like radicals, the first thing I want to do is check to see if I can simplify. Okay, can I simplify radical 3? Well, that's already simplified. Radical 48. Okay, I can simplify this. What I have to think about again is, do I have any perfect squares that go into 48? So you're going to have to use your perfect square number line, your perfect square list again. But 48, I can think of, okay, that is radical 16. And that's also going to be 3, right? So 16 times 3 gives me 48. 16 being a perfect square, that's going to simplify down to 4 radical 3. So as a result, when I simplify this, I'm going to get radical 3 minus 4 radical 3. This can be simplified. Now just think about a variable. This radical 3 is like saying, variable-wise, that I have x minus 4x. When we do this, you got to think, what is the number in front of x? The number in front of x is a 1. So what's the number in front of this radical 3? It's also a 1. So this becomes 1 radical 3 minus 4 radical 3. That's going to give me negative 3 radical 3. So check to see, can we simplify? And notice that when I simplified this down, it simplified to radical 3, which matched what I had there. So keep that in mind. When you simplify, you maybe want to get them to match. All right, next one, I have 4 radical 2 plus radical 3 minus radical 2. All right, so this would be like saying, again, if you look at this one, we have our radical 2. So this would be almost like saying 4x, and this would be like saying minus x. But notice I got a radical 3 in there, a different radical. This would be like saying plus y. So notice I got a different variable in there, a different radical. So again, combining like radicals would be like saying combining 4x and x to get 3x plus y. And then I can't simplify these last two because they're not like terms. Now, if we take and apply this to radicals, this would be combining these two radicals together. 4 radical 2 minus radical 2 would give me 3 radical 2, and then plus radical 3. I can't simplify those. I can't add what's on the inside, so that's going to be simplified. Okay, so not that bad, just looking for like radicals. All right, next one we're going to have to simplify both. We got radical 90. Let's see, what are some numbers that go into 90? We got 9 and 10. Let's see, 16, 25. So it looks like 9 and 10. So let's do radical 9 and radical 10. Radical 9 is 3, so I'm going to get 3 radical 10. Again, simplifying from section 1. Minus 40, let's see, 40 we got, let's see, what do you guys think? Maybe 4 and 10, right? So 4 radical 10. Okay, when I think about this, notice how at the end I get radical 10. So maybe I'm going to try and think, oh, maybe I can simplify these so that what's left over matches. Interesting. So that's going to be minus 2 radical 10, because radical 4 simplifies down to 2. And in the end, that's going to be 1 radical 10, or you can simply write that as radical 10. Fantastic. Okay, so adding and subtracting is just like combining like terms. All right, next thing we're going to look at is multiplying and dividing radicals. So multiplying radicals is something we've already done, is what's called the product property of radicals. We did this in section 1. That what you can do is you can take something with a product and you can break it down into 2 separate radicals. So if I just take this and flip it, if I say radical A times radical B, sorry, that's an A. If I want to simplify this, I can basically take the radical, or the square root, of A times B. So I can do the opposite of what's shown here, go back this way. So I can use that to simplify radicals. Let's see what happens here. So as for example, be careful, this is not 2 radical 2 minus, but notice there's the dot there to represent multiplication. So I have 2 radical 2 times negative 4 radical 6. So using the product property, I'm going to take whatever's inside the radical. I have radical 2 and radical 6, and I can write that underneath one radical. It's going to be 2 times 6 underneath. Now, what do I do with the numbers on the outside, 2 and negative 4? Okay, well, remember, numbers on the outside we're going to keep on the outside, so this is going to end up being 2 times negative 4 on the outside. So what does that end up giving me? I'm going to get negative 8 here, and then I'm going to get radical 12 right there, negative 8 radical 12. So simplify rule here is I'm going to take the numbers on the outside, and I can multiply them together, and I'm going to take the numbers inside the roots, and I'm going to multiply those things together. So we're going to combine whatever's outside, combine whatever's inside. Now the last thing I'm going to do in all these problems is you're going to check to simplify. Can I simplify radical 12? Okay, well, let's think. Are there any perfect squares that go into 12? Well, yes, there are. I'm going to go back to blue. I'm going to have radical 4 and 3. 4 times 3 is 12. What is radical 4? Well, radical 4 is 2. So I have 8 times 2 times radical 3. That's going to give me negative 16 radical 3. Boom, simplified. Perfect. All right, next one. Oh my gosh, I got 4 radical 7 times, in parentheses, 3 radical 2 minus 2. Notice I have 2 terms here, separated by the minus sign. What does this look familiar to? Well, this looks familiar to, I'll give you a simple example, 4 times 3 minus 2. Okay? Even heck, think of radicals as a variable, put an x here. What can I do? I can distribute. So when I look at this example, I'm going to distribute 4 radical 7 here and 4 radical 7 there. Okay, now let's combine this with what we did in example 5. When I distribute, any numbers on the outside of a radical I'll combine, any numbers on the inside of a radical I'll combine. I'll draw this out for you nice and long. So I'm going to have 4 radical 7 times 3 radical 2. That's the first term. Then I'm going to have minus 4 radical 7 times 2. Okay, got the minus sign from right in there. Now let's see if I can combine these. Again, I'm going to combine 3 and 4 on the outside, so that's 2. 7 and radical 2 I can combine to get radical 14. That's going to be minus. I have 4 and 2 both on the outside, so that's going to give me 8, and then radical 2 on the outside. Last thing I'm going to do is check to see, can I simplify? Well, first of all, I have radical 14 and radical 2, and I'm subtracting these two things. All right, so can I simplify this? Well, we got to look at 14. 2 is simplified, right? We can't get any perfect squares out of 2, so let's look at 14. 14, we got 1 and 14 and 2 and 7. Are either of those going to be perfect squares? Okay, no they're not. So, can I simplify 14? No. So I have to basically leave it as is. So my answer is this, simplified. Since the radicals are not like radicals, I cannot simplify it. Common mistake for kids to do is say, okay, 12 minus 8 is 4, and 14 minus 2 is 12. This is incorrect. I cannot do this. This right here would be my overall answer. This is good, as nasty as it may look. Okay, so this, using the product property of radicals to simplify. All right, here we go. Let's talk about dividing. Well, this is using what's called the quotient property. So the product property says that if I take two radicals and divide them, so if I take the radical of a divided by b, what I can do is split this up. Just like multiplication, I can do radical a divided by radical b. The same thing can be said if I go in reverse. If I'm dividing two separate radicals, I can write them underneath one radical. Okay? So let's take this first example, radical 16 over 49. The way I can treat this is, since I'm dividing both 16 and 49, which don't go into each other, I can take radical 16 and radical 49 and separate them, split them up. Why is that useful? Well, because radical 16 is 4 and radical 49 is 7. So this simplifies down to 4/7. Okay? So I can split it up. Same thing here. Next, radical 121 over 25. I take the square root of radical 121, divide by radical 25. Now I can simplify. Radical 121 or square root of 121 is 11. Square root of 25 is 5. I get 11/5. Easy peasy lemon squeezy. Excellent. All right, so the next thing, we talked about adding like radicals or subtracting. We talked about the product property. We talked about the quotient property. The next thing we're going to talk about is something that's a little tricky, and it's called rationalizing the denominator. Okay, rationalizing the denominator, what does this mean? Well, when we rationalize the denominator, what this means is that we do not want a radical in the denominator. It is not necessary. It's something we don't want to do. It says up here it's not appropriate. We don't want to do this. Okay, so you see in example 9 how we have radical 11 inside, in the denominator of this fraction. We do not want a radical 11 there. So the question is, if we don't want it there, that means we have to get it out. Well, how the heck do I get radical 11 out of the denominator? And what we're going to do is a process called rationalizing it. Okay? By rationalizing it, we are going to multiply whatever number we have. In this case, 3 over radical 11. We're going to multiply it by a form of 1. Oops, I wanted to use my highlighter tool. A form of 1. What do I mean by that? Okay, well, here's what we're going to do. Do you see how there's radical 11 in the denominator? In order to rationalize this, what I'm going to do is I am going to take this and I'm going to multiply it by radical 11 over radical 11. Now, you may look at that and say, what the heck, why are you doing that? Well, I'm going to tell you right now that by multiplying 3 over radical 11 by this is not changing anything. You may not understand it, but I want you to think. Radical 11 divided by radical 11, the number I'm multiplying right here, okay? Think about this. Use our quotient rule. This is radical 11 over 11. Well, what's 11 divided by 11 inside? 11 divided by 11 is 1. So I'm going to get radical 1. And what's the square root of 1? It's 1. So what I'm doing is I'm technically multiplying by 1. And if you take anything multiplied by 1, you're not changing anything. So technically I'm going to make this look different, but it's not going to mean anything else. Basically, it's like taking a person and putting makeup on them. They might look a little prettier, they might look nicer, but it doesn't really change the person at all. Okay? So when we do this, we're going to use some rules. Right here I have 3 times radical 11. That's going to become 3 radical 11. Cannot multiply those because I have one not in a radical and one within a radical. Now the bottom I have 2 radicals, so this is going to give me radical 11 times 11. Which, simplified, now I'll write it down here, is going to give me 3 radical 11 over 11 times 11 is 121. Now I'm going to look to simplify. Well, 121, the square root of 121 is 11. So I get 3 radical 11 over 11. So what ended up happening if I look from the original position, which is right here. I wanted to use my pen tool again, I'm sorry, to right here. What happened? Notice how radical 11 simply turned into 11. Wow. So what I ended up doing was getting rid of that radical in the denominator. Okay, and right here, this is my answer. That is simplified by rationalization. Okay, all right, next one, we have 1 over radical 4. So again, I have this radical 4 in the denominator, so I'm going to multiply it by radical 4 over radical 4. What is that? That is technically 1. That's going to give me 1 radical 4 over, and again, radical 4 times 4 is 16. That's going to give me 1 radical 4 over, what's the square root of 16? That is simply 4. So you're going to get 1 over 4, sorry, 1 radical 4 over 4. Boom, done. Okay. Next one, I have radical 8 over radical 5. So this one you might link, okay, I'm going to use my my quotient rule, I'm going to get radical 8 divided by radical 5. When I do this, however, I have a radical in the denominator, and I can't simplify this. There's no perfect squares that go into it. I can't take the square root of both these numbers. So instead, I am going to do radical 5 over radical 5. I'm going to rationalize it. Okay? Now, shortcut here, radical 8 times radical 5 will give me radical 40. What happens when I have radical 5 times radical 5? What do we notice? Radical 11 times radical 11 ended up being 11. Radical 4 times radical 4 ended up being radical 4. So, can anyone think of a shortcut? Well, when you take two radicals that have the same thing and you multiply them, the radical is going to disappear. It's going to give you 5. Now, I can't take 40 divided by 5 because 40 is inside the radical, but I can certainly simplify 40 again. Oh my God, this has everything in it, folks. Okay, so I'm going to do this. I'm going to take radical 40, and that's going to be radical 4 times radical 10. All that over 5. Well, radical 4 right here, that's 2. So I'm going to get 2 radical 10 over 5. Holy cow. All right, I might have lost some of you there, but just follow along, follow those steps, see if you can figure out what I did. Okay, let's do that same type of problem. Let's go ahead and do this in number 12. So this one I have radical 12 over radical 6. All right, so you might say, hey, let's split this up, use the quotient rule, radical 12 over radical 6, and then rationalize it. Well, real quick, some of you might be like, okay, let's rationalize, let's rationalize. Some of you might be saying, wait a second, big dog. 12 divided by 6, that's 2. So why can't I bypass this whole entire thing and just get radical 2? Well, you can. Boom. That's my answer. So always check what's inside. Always check to see, can I divide 12 and 6? Can I divide what's inside the radical signs? Yeah. And if you can, guess what? It's going to simplify right away. And then I cannot simplify that anymore, so that's my answer. Okay, so this is rationalizing. Again, this is going to be the tricky part of this section, so make sure you get some extra practice at it. All right, I'm going to do 13 and 14 for you guys. 15 and 16 is going to be on you. So let's take a look. Number 13, you got adding and subtracting. Again, I see the adding and subtracting, so understand the difference between these and obviously multiplication, which we'll do in 14. So I'm going to look to add like terms. I see radical 28. Let's see if we can simplify that. Okay, 28 I know right here is going to be radical 4, radical 7. So I'm going to have 2 radical 4, radical 7. Well, guess what? That's going to be 2 times 2 radical 7, which is 4 radical 7. So this one becomes 3 radical 7 minus 4 radical 7. And then let's look at the radical 63. Well, how do I get radical 63? Well, we can think of 9 and radical 7. Whoa. And radical 9 is 3 radical 7, so that's going to give me plus 3 radical 7. Now, how do I combine these? Notice all the radicals are all the same. So all I'm going to do is take 3 minus 4. So 3 minus 4 right here would be negative 1. Take the 3 with it. Plus 3 would give me 2 radical 7. Simplified, bing, boom, bang. Let's go. Number 14, we have 3 radical 3 minus 2 radical 2. Notice we have this to the second power. Ooh, sassy, S-A-S-S-Y. How the heck do I simplify this one when we throw a power in here? Okay, what does that exponent mean? What does the power 2 mean? Well, it means I'm going to take whatever's inside. 3 radical 3 minus 2 radical 2. Those 2's were nasty, I apologize. And I'm going to take that and multiply it by itself. 3 radical 3 minus 2 radical 2. Wow. Okay, now what am I going to do here? Well, I'm going to take this, and what do I do to simplify? I'm going to have to use our favorite FOIL method. Double distributing. I'm going to have to distribute this to that, this to that. Let's see if I can do this quick without showing all the steps. I'm going to take the outside numbers 3 times 3, which is going to give me 9. Take the inside numbers 3 and 3 and give me radical 9. Okay? Then I'm going to take 3 and 2 to get negative 6. Again, it's a negative. And radical 3 and radical 2 will give me 6. Now the second one, I'm going to distribute the second term all the way through. So negative 2 radical 2 times 3 radical 3. This is going to give me negative 6 radical 6. And then negative 2 radical 2 times negative 2 radical 2 will give me plus 4 radical 4. Whoa. Whew. Okay, so I got my 4 terms there. Very good, very good, very good. Now let's see if we can combine things. Okay, so let's see. Can I simplify anything in this first one? Yeah, look at, hey, radical 9. What's the square root of 9? That's 3. This becomes 9 times 3. And then I have minus 6 radical 6. I can't simplify. Again, 6 radical 6. We'll save that for a second. And then 4 radical 4. Can I simplify anything here? Yeah, we got the 2. So that's going to be 4 times 2. Let's see if we can go any further. 9 times 3. That's 27. Notice here I got radical 6's in both of these, so we can combine these like negative 6x and 6x. Let me just put this down here real small. This would be like saying negative 6x minus 6x. We can combine those to get minus 12 radical 6. Again, they're not x's, but we can treat them like that. And then lastly, I got plus 4 times 2 is 8. And the last thing I can do is combine my like terms. I get negative 12 radical 6 plus 27, and 8 is 35. Holy camole, that is my answer. That's a lot of meat and potatoes right there. We got a little multiplying, we got some simplifying, we got some adding, we got some subtracting. Holy cow, that's fantastic stuff. All right, now I'm going to see if you guys follow numbers 13 and 14. I want you to give number 15 and 16 a try. So pause the video, give those a whirl, see what you get. All right, go ahead, pause. All right, take a look at what we have here. First example, again, I just wanted to simplify radical 12 and radical 27 into these two, which I did. Simplifies down to 2 radical 3 and 3 radical 3. Combined the 2 that had the radical 3 to get me negative 1 radical 3, but the 2 radical 5 cannot be simplified, so that stays by itself. Next one again is sassy. This one looks like number 14. Again, the square means that I have this multiplied by itself twice. So then I distributed. I know I didn't show my lines here, but I took 4 radical 5 there, and then here and here. And I got down here 16 radical 25 minus 12 radical 10 minus 12 radical 10 and 9 radical 4. Simplified this down to 5. Simplified this down to 2, and then combine these two to get negative 24 radical 10. 16 times 5 is 80. 9 times 2 is 18. Combine 18 and 80 to get 98. Can't combine the 24 radical 10. Radical 10 cannot be simplified, so that means my answer is simplified. Okay? All right, guys, again, this is going to be a little challenging. 14, 16, those are the two sassiest problems. And make sure, if you have any questions on this stuff, jot it down. I know there's only 2 sections in this unit, but you can tell that 11.2 has a lot of meat and potatoes in it. Okay, so make sure you ask plenty of questions. All right, guys, I hope you enjoyed. We'll see you in class. Good luck on the mastery check. Peace out.